Greetings, dear colleague. My name is Andrii Kopp. I'm Associate Professor of the Department of Software Engineering and Management Information Technology of National Technical University, Kharkiv Polytechnic Institute, located in city Kharkiv in Ukraine. And I'm glad to present my talk, Educational Data Analytics with Python. Let's start with the first thing, what is Python? And Python is a programming language widely used by data scientists. It has inbuilt mathematical libraries and functions, which make it easier to calculate some mathematical problems and also to perform data analysis. In addition to Python, data scientists use its libraries, which are, for example, pandas, the library used for structured data operations like import and processing of comma-separated value files, creating of data frames, and preparing data. NumPy, the mathematical library, which has powerful n-dimensional array objects, linear algebra operations, Fourier transformations even, and others. Matplotlib, the library which is used for data visualization, and SciPy, the library which has linear algebra modules. What is data science? Data science could be considered as combination of multiple disciplines that use statistics, data analysis, machine learning to analyze data and to extract knowledge and insights from the data. In general, data science is about data gathering, analysis, and decision making. So data science is about finding patterns in data through analysis and for making future predictions. By using data science, companies are able to make better decisions, to perform predictive analytics, and to discover some patterns from data which are hidden but valuable for business decisions making. Who needs data analytics, why, and when? Actually, data science is used in many industries in the world nowadays, for example, for road planning, to predict delays of flights or ships, and so on, to create promotional offers, to find the best time for goods delivery, to predict the revenue of a company, to analyze health benefits from sports training, or to predict who are going to win elections. Also, data science can be applied in almost any part of a business where data is available, like consumer goods, stock markets, industry, politics, logistic companies, or e-commerce business, and many others also. Who are data scientists and how they work? A data scientist is a person and IT specialist who requires expertise in several backgrounds like machine learning and first of all statistics, programming using Python or R languages, mathematics and databases as well. Data scientists must find patterns within data. Before he or she can find the patterns, data scientists must organize the data in some standard format. So the typical workflow of data scientist work includes following steps like asking the right questions to understand the problem, explore and collect data from different sources, extract the data and clean it from errors or missing values, find and replace missing values also, then normalize data so the values will be scaled in the same range, analyze data, find patterns, and make future predictions. And finally, represent results so the useful insights for the company can be easily understood by stakeholders. What is data? We can understand data as some collection of information, and one of the purposes of data science is to structure data and make it interpretable and easy to work with. Data can be categorized into two groups: structured data, which is organized and easier to work with for computers, and unstructured data, which is not organized. And the task for data scientists is to organize the data for future analytical purposes. What is structured data? What does it mean? For example, we can use an array or a database table to structure or present data in future. And a database table is basically a table inside the computer with the structured data. And the following table we're going to consider as the example shows us a database table with several parameters which are considered important during the undergraduate students application for master programs. Such table contains 8 meaningful columns for us, which includes some exam scores, university ratings, and statement of purpose, and letter of recommendation strengths, and GPA score of students, research experience, and finally, a chance of admission. And in general, the database table consists of columns and rows. As you may see, a row in a table is a horizontal representation of data, some description of particular data object, and column is a vertical representation of a data, as you may see. So a variable is also should be considered is something that we can measure or count, and examples could be character data, some numerical data, date, and time values, for example. And in our sample data set, we can observe that each column represents a certain variable like strength of purpose or GPA score or TOEFL score exam, and so on. And since we have 8 columns in our sample data set, that means that we have 8 variables. And also there are 400 rows in our table. So that means that each variable has 400 observations. And before analyzing data, we need to prepare it. So the data scientist must to extract a data and to make it clean and valuable. And before data can be analyzed, it must be imported and extracted to the system. So in the example below, we demonstrate import data using Python and pandas library. We use the read CSV function. It's extremely simple to import a CSV file, comma separated values, with the undergraduate students admission data I just demonstrated on the previous slide. So after the data preparation, we need to understand to which categories our data belong. So to analyze data, we need to know the types of data we are dealing with. And basically data can be split into 3 main categories: numerical data, which contains numbers, and in their turn, there could be discrete numbers like whole numbers. For example, university ratings could be 1, 2, 3, 4, or 5, or there could be continuous numbers of infinite precision. For example, undergraduate students can have GPA of 8.87 or 9.34 or 7.9 and so on. 2 more categories of data are categorical data, which are values that cannot be measured up against each other. Like we can't compare type of research experience, which one is better than another. And ordinal data, it's categorical data that could be measured up against each other, like GPA scores could be compared, like one score is better than other score, and so on. And actually, by knowing the data type, data scientists could be able to know which technique they could use in future to analyze data and obtain some insights from the data. And we can use the info function of pandas library in order to list the data types within our data set. And as you may see, for our data set, we have two different types of data: integer numbers or discrete values, whole numbers, and floating point values, continuous numbers with infinite precision for special columns demonstrated in the results after we printed the data which info function returns. And now let's see what we can do with our data set by means of Python statistics functions. So first of all, let's see that three commonly used functions when working with data science in Python are max, min, and average or mean function. And first of all, the Python's max function is used to find the highest value of a variable. It's shown here. We use it to find the highest value of GPA value. We just selected it from the all data set we put before in the admission data variable, and sent this parameter as the argument for max function, which is native in Python. And we had, for example, this result. It says to us that we have the maximum GPA score is 9.92 among all students' observations. Another function is min. It is used to find the lowest value of a variable. It's also native function in Python. And for example, here we got that the minimum GPA score for all students is 6.8 in our sample data set. Now we deal with the mean function that is used to find the average value of some dataset variable. And in contrast to functions presented before, mean is not native Python's function. It belongs to the NumPy library that must be important first of all, and then used called in the same way, but as others functions, also to calculate the average value of GPA scores in our data set. And as the result, here we obtain that average GPA score for undergraduate students we have in our observations is 8.59 and some other digits. And one more interesting function we can use, and more advanced concept, are percentiles. They are used in statistics to provide us with the number of that describes the value that a given percent of the values are lower than. So it means that, for example, the 25 percentile of GPA means that 25% of all the students have a GPA of some value or lower than. And if we flip this statement, it means that 75% of all of the students have a GPA of some value or higher than this value. And the same is for 75 percentile. So we used again NumPy library to use its function percentile and to find two values: 25 percentile for all GPA scores of observed student records, and 75 percentile for GPA score of all students' observations. And in contrast to functions displayed before, percentile function from NumPy library needs not only a single argument of the variable we're going to process, but also as the second argument we pass the exact value of percentile we expecting to calculate. So as the result, for example, we got two numbers for 25 percentile and 75 percentile, 8.17 and 9.0625. This means for 8.17, this means that 25 percentile of 25% of all of the students have 8.17 GPA score or lower. And for this 75 percentile of 9.0625, it means that 75% of all of the students have a GPA of 9.0265 or lower. And we can also flip these values, as I mentioned before. But besides percentiles, there is one more complicated concept in data science and statistics, which is standard deviation. It could be simply considered as a measure of uncertainty. So, for example, a low standard deviation means that most of the numbers are close to the mean or average value, but high standard deviation means that the values are spread out over a wider range. And we can also use NumPy library in order to find the standard deviation of some variable. We again used GPA score of undergraduate students as a variable to calculate its standard deviation. And here, as the result, for our sample data set of observations, we got 0.59 as standard deviation for GPA scores, which says it's pretty low value, and the most of GPA obtained by students are close to the average GPA score calculated and displayed on previous slides. And it's better to see some visualization, and this picture well describes the concept of standard deviation through the mapping of this measure to normal distribution graph. And also the most important benefit when using Python is that we can start analyzing our data immediately. And all of these functions which calculate statistical data, statistical measures, could be found at once by using describe function in pandas library of Python to summarize the statistical measures of all the data set or its particular variables. And it allows us to find the number of observations, the average value for each of variables, standard deviation, of course, lowest and highest values, and 25, 50, and 75 percentiles. So, for example, if we call the describe function on our variable that represents undergraduate students' GPA scores, we receive the following outcome and printed to by the Python. And we can interpret this data as following. After we processed 400 observations for students' GPA, we discovered that average GPA is 8.59, minimum GPA is 6.8, and maximum GPA is 9.82. We also find out that all GPA's scores of all the students' observations are in general close to the average value by means of analyzing the standard deviation. And we can say that 25% of all students have 8.17 or lower GPA, 50% of students have 8.61 GPA or smaller than, and 75% of all of the students have 9.06 GPA score. and greater than this score, 9.06, have only 25% of all observed students. And in total, all of these data exploration and data processing and analytics took just such amount of code in Python, which makes it extremely convenient, even sometimes more convenient than, for example, Excel data processing. And this is the most important benefit of using Python for data science and business data analytics. And I hope that such example on educational data was clear and understandable. So thank you all for your attention. Feel free to contact me to ask your questions.